All right, guys, so we are going to go over valence electrons and groups. We're going to review that before we begin today's lesson because, again, every day we build off of what we did the day before. Okay, so first of all, remember that electrons in an atom have a certain placement, and so there's rules that we need to follow. For example, the first shell, which is closest to the nucleus, can only hold 2. The second shell can only hold up to 8, maximum of 8. Third shell can hold up to 8 as well. And then remember, if the atom is bigger and needs another shell, it can hold up to 8. So the biggest or the largest number of shells you can have is up to 7, but the pattern stays the same. It's 2, 8, 8, 8, 8, 8, 8. Okay. Now this is important because when we start looking at valence electrons, okay, we're referring to, when you hear this word, think about electrons on the outside shell, on the last shell, on the shell that is farthest from the nucleus, or the ring that's farthest from the middle. Okay. Here, in this picture, we would only be looking at these. So 1, 2, 3, 4, 5, 6, 7, 8. So this atom here has 8 valence electrons. Okay. Now, it was important because then we last week also talked about groups, okay, and then the pattern in the group. And so we know that those valence electrons in each group are going to be the same. So, for example, group 1 will all have 1 valence electron. Group 2 will have 2. Group 13, because remember, we skip all this middle area. We ignore it for now. When looking at the patterns, we ignore it. We don't look at the transition metals. We go to 13. So group 13 will have 3. Group 14 will have 4, group 15 will have 5, group 16 will have 6, group 17 will have 7, and then group 18, we have a slight difference. So all the other ones will have 8, but helium is also in group 18, and I had a lot of questions about this. So remember, the most you can have on the very last shell for helium is 2. So helium, remember, it only has 1 ring and it has 2 electrons. So we say that that shell is full. We can't fit any more in there. All right. And if you look at these, all the other ones, so this is neon, argon, and so forth, have 8. Well, again, those last shells can hold 8 and no more than that. So they're full. So in group 18, you look to see if they're full. And so that's why helium fits with group 18, because it's full. All right. And this plays an important part in reactivity, which is what we're going to be learning today. So today, you should be able to determine how reactive an atom is by looking at the number of valence electrons. Okay. So that's what we're going to be focusing on today. The word reactive, the word reactivity, and connecting it to valence electrons. If you have any questions, please feel free to ask. Remember, guys, we're getting close to report card time, so we want to make sure you understand all this information. Thank you.